This podcast involves us looking at descriptive statistics in political science research. We are still using what are called large N data sets, or data sets with many cases in them. These are quantitative data sets, meaning that the data are numerical. We have two different ways to think about these large N data sets. One of them is called descriptive statistics, and the other is called inferential statistics. Descriptive statistics allow us to make conclusions about the sample by simply describing what the variables look like. Inferential statistics allow us to apply the conclusions from a sample of data to a larger population. In other words, we're able to make inferences. I'll be sure to note the difference between descriptive statistics and inferential statistics as we go through these podcasts in this module. For now, we'll focus on descriptive statistics. Descriptive statistics involve us thinking about measures of central tendency and measures of dispersion. We'll start with measures of central tendency. In general, these descriptive statistics are meant to tell us the typical value of a variable for our sample. So from a large array of data, we want to get to the heart of the matter relatively quickly, and thus figure out, well, what is the typical value in this data set? There are three ways that we can determine this: through the mode, the median, and the mean. And I'll go through each one of these. The mode is simply the most common value in a variable. By hand, we can simply arrange the values in our data set from smallest to largest and find the one that is most repeated value for that particular variable. For example, for a very small data set, say values of 5, 8, 3, 4, and 5, we just rearrange the values from smallest to largest, 3, 4, 5, 5, and 8, and the mode is 5 because it is repeated the most times, twice in this small data set. Sometimes there will be no mode because there will be values that will have been repeated an equal number of times, and sometimes there will be data where there are no values repeated at all, so there will be no mode. So in those cases, the mode is not particularly useful. The median is simply the middlemost value of a variable, and it cuts that distribution of values in half. 50% of the lowest values and 50% of the highest values. So it is that midpoint of the distribution of values. Now, how do we do this? Well, for an odd number of observations, we just simply arrange the data from smallest to largest. So say if we had a data set of 5 values, we would just arrange it from smallest to largest, and then find the middlemost observation. And that observation is the median. If for our same data set, 5, 8, 3, 4, and 5, a very small 5-case data set, we rearrange the values so that we have the smallest first, 3, then 4, 5, 5, and 8, the largest value. That third observation is the one that is in the middle. In other words, 50% of the observations are below it and 50% are higher. The third observation is a value of 5, so 5 is the median. Now for the mean, the sum of the set of values divided by the total number of observations, this is also known as the average. So we add all the values together, and we divide the sum by the total number of observations. We've used averages for most of our mathematical life, so I don't think this one is going to be particularly surprising. For instance, with the mean, for a small array of data, 5, 8, 3, 4, and 5, we just add them up in any order. We come up with the value of 25. 5 plus 8 plus 3 plus 4 plus 5 is 25. And we divide by the total number of cases, or the n. 25 divided by 5 is 5, so 5 is the mean value. So what should we use these different measures of central tendency? The mode is very useful in terms of a categorical variable, and also variables without order. So party identification is a categorical type of variable, where people put themselves into various categories, and variables without any particular order, such as gender identification or one's state of residency. For instance, are you a resident of Idaho or are you not a resident of Idaho? And sometimes variables with numerical values that have orders such as income and age are also analyzed well by the mode. For the median and mean, if you have variables that have values that have a specific order in mind, then the median and the mean become particularly valuable as measures of central tendency. We'll move to measures of variability. This is the second class of descriptive statistics. And variability simply asks us about how often, on average, do observations deviate from the mean value. So we're going to focus on the mean. Do most observations take on values close to the mean or far from the mean? For example, I have two very small data arrays, 4 cases each, and the mean is 10 in both of these variables. But one variable has a very small amount of variation. We can see that 10, 10, 8, and 12, small amount of variation in comparison to 0, 10, 20, and 10, larger variation. So for that first data set, the observations do not deviate from the mean much at all, but for that larger variance data set, they do deviate from the mean quite a bit. So that's interesting information. There's a lot of variation in our variable that tells us something about the behavior that is captured by that variable. So the formula for sample variance involves something called S squared, and that is the abbreviation that's used for variance. It's equal to the sum of the squared deviations from the mean value divided by the total number of observations minus 1. So x sub I is simply each observation, x bar is the sample mean, and n is the number of observations. And that's how we calculate a variance, which tells us, to a certain extent, just how widely values within an array of data vary from one another. The sample standard deviation is simply the square root of the variance. And the sample standard deviation is used quite a bit because it is a more intuitive type of measure of variation. The larger the variance in standard deviation, the more often observations deviate from the mean on average. In the next podcast, we're going to consider the use of scatter plots.